Are you already using AI in your steel plant? Or are you still skeptical about AI? Well, the good news is that for all of you, within the next 60 minutes, we should have interesting content. Welcome to the Pioneers Talk Beyond the Hype, AI for Operational Excellence in Steel Industry. My name is Christoph Stangl and I will be your moderator. Well, today we want to discuss in detail about the use of artificial intelligence in steel production. We want to answer questions like, for example, what are the benefits for you of using AI in steel production? What are successful use cases? What are the limitations you should consider? Why does metallurgical know-how play such an important role? And what are success factors for you to successfully apply AI? To answer these questions, I have invited two experts in digitalization and automation. On the one hand, it's Kurt Herzog. He is Head of Industry 4.0 at Primetals Technologies. Welcome, Kurt. And on the other hand, it's Dr. Alexander Thekale. He is Technology Officer for the Global Business Unit Electrics and Automation at Primetals Technologies. Welcome, Alex. If you have any questions to our speakers, please input them in our chat at this live stream. We will have Q&A sessions later on to answer the most interesting ones. Before we start, let me share 3 facts about AI in steel production I have collected prior to this talk. First, the consulting company Crow published a report revealing how the steel industry is adopting technology. So what do you think? How many steel companies planned in 2023 to adopt AI? It was actually 41%. Second, I visited websites of the biggest steel producers to look out for where they have incorporated AI in their missions and visions. Maybe you know these statements better than I do. But I found that, for example, ArcelorMittal has developed a holistic vision incorporating big data and artificial intelligence, or the CEO of Outokumpu already leverages AI to improve efficiency. And third, I found an analysis by Boston Consulting Group stating that by connecting assets through data and by generating insights, steel producers can increase the product yield by more than 15%. So obviously, it makes a lot of sense to apply AI to steel production. But I have the impression that exactly such numbers, which I just presented, are creating a huge hype, sometimes lacking a solid knowledge base. I'm very sure that you have already quite some experience with AI also as a private person. You have an opinion, you and you as well. This makes it so difficult to discuss about AI on a common ground. By the way, it would be great if you would input your experience with AI in our chat. From my own experience as a marketer, I know that in many areas using AI can be done without any problems. For example, when I create a piece of content, it's not a problem and sometimes desired to hallucinate a bit. But what about AI in steel industry? The situation there, in my opinion, is totally different. And so I'm glad that we can now discuss how steel producers can successfully achieve operational excellence by using AI solutions. Let's start to discuss what AI really stands for in the steel industry so that we are all on the same page. So Alex, maybe you can just elaborate a bit on this, what AI means when we think about steel production.
We would need to check if AI is the proper method to solve that anyway. So you have these two big parts of experience and knowledge you need to have really to be able to apply AI in steel industry.
Okay, thanks for that. And I suppose when we talk about using AI methods in steel industry, that of course data is the most important source, and data is the new oil is an old statement and saying. So Kurt, when we talk about like data in steel industry and when we want to use AI methods to generate insights out of data, what are, in your opinion, like requirements to data to be able to apply AI methods properly?
Requirements to data. We all know lots of use cases. For example, in the area of B2C, where AI, machine learning methods, prediction, database prediction methods bring incredible results. And if you, for example, take one of those big internet sales platforms, I don't want to, I think you all know what I mean. I don't want to mention one of them. Each purchasing on this platform, each transaction has a very, let's call it, well-defined set of data. Well-defined means correct data, not that many different data points. So maybe per sales transaction, maybe 30 or 40 data points. And they are independent from each other. And this is a great basis for machine learning. If you look at steel industry, steel production, let's say if I talk about product quality, for example, there is, I don't know, 8,000, 10,000 parameters from the melt shop to the finished product that are quality relevant. So there's a huge amount, a huge number of data. Plus, the data is not independent. That means if you look at the finished coil, from 1 meter to the next, the data is not changing that much. So I don't have this fidelity in the data. The data is not independent. And we are all collecting data via measurement instruments. And we all know that measurement instruments provide values, and those values are always coming with some error. So when we build AI applications that use this data, we have to be well aware what the quality of the data is. So I cannot take the data for granted. I have to understand where can be errors on the data, what are the dependencies between the data, and things like that to build proper applications. So let's assume we know how to deal with the data, to treat the data. We have a complete, correct data set. Now we build machine learning applications. What do they provide? Typically precondition, predictions, things like that. But value out of data is only generated if I trigger action based on this data. Means a model that provides me prediction doesn't bring any benefit. If I look at the weather forecast, and the weather forecast says it will be raining, and I don't take my umbrella with me, I don't have a benefit of the weather forecast. Same in the steel production. Knowing things doesn't help. Changing things because I know better. Acting on this information that changes, and this is very important to really make data work. And when we talk about AI in steel production, we're always aiming for closed loop control. Means more or less action automatically generated out of this data. And therefore, robustness, correctness of the actions of the systems we are using, of the actions that are taken, are extremely important. If you use AI to generate some marketing text, okay, you will have a look at it, and if there's something wrong, you correct it. But if AI is working in a closed loop control system, it has to work properly. This is one of the big challenges. Correct data, complete data, and the right data is a precondition to do that.
Okay, thanks. Good. Alex?
You have touched two very important points, Kurt, on that topic. The one is having the right data at hand that you need to apply AI. But as we are living in our steel plants in a heterogeneous environment with a lot of different automation systems, sometimes provided by different companies. Data integration is also an important topic. And to be able to collect the data out of these different systems we need the data from, and then to have them at a very high quality is crucial. So also to have experience in that, to have access to the automation systems, to the different kinds of automation systems, also plays an important role if you would like to add AI to your system.
And when we now talk about applying now really AI to a system or to find a solution, could you mention that actually the quality of data is very important? So if you now suppose we have the right data in place, the quality of the data is fine. At the beginning, Alex, you mentioned that there are a lot of like different AI methods principally available. Is it then like not important which AI method I take? Can I use everyone, or how do I decide which AI method I should take to find a solution to my problem?
It's absolutely crucial to find the correct method for your problem. There really exists a lot of different methods dedicated to a special type of problem. This could be, for example, what you see very often in the media, like computer vision based, so AI based seeing topics, but could also be AI based hearing topics, could be AI based evaluation of sensor data for, let's say, condition monitoring purposes to know what's the state of your equipment. You can run AI topics on the quality of your data. And for all of these different applications, there exist dedicated methods, and this needs to be evaluated by experts in the AI field to know which method to use.
Very good. Okay, thanks.
And I would add another comment here. It's not only the application, the technical application of these methods, it's also always a discussion on fulfilling also regulations. For example, the EU released the EU AI Act. So not everything that's technically possible is also allowed. You also need to consider that.
Okay, very good point. Yeah, I think recently there came up quite some regulations, right? Yeah. Very good point.
And there is also one restriction in addition. People are still working in the steel plant, in the production. And people have to accept and collaborate with AI. And therefore, it is also important to not only do the right things, but also explain why actions are taken, explain why proposal for actions are made, what is the reason behind it, to take the operator to the journey and not overrule the operator. This is extremely important. If operators, if process engineers do not understand any longer why actions are taken, why decisions are made, there is an immediate mistrust, and the acceptance of the systems will not be there. So it's not replacing human decision making by AI decision making. It's more a joint decision making, a supported decision making, and a continuously growing know-how in the digital systems, and not the one against the other.
So you mean that actually the training effort for AI-based solutions is higher than for like regular ones when it comes to the adoption?
I don't know if the training effort is higher. The important thing is that it's not seen as a competition, and the human can learn from the AI, and the AI can learn from the humans. So with very simple, this is not complicated technology. If you look at the good old expert system, what we do, for example, is that an expert system can be operated in closed loop or in almost closed loop. And in almost closed loop, the expert system informs the operator, I will take this action now because I found out that this and that happened. And then the operator can confirm, and then the action is executed. or the operator says, no, I don't think you're right. And why, the reason why I don't think you're right is the following, and he has to log that. And if you do that, then you can improve your rule set in the expert system in case the operator was right. Means the digital system learns from the operator, or the other way around. If the expert system was right, you explain to the operator what's going on, and then the operator learns from the system. And then doing that, there is a continuous joint learning system and operators. And I think that this aspect is extremely important when it comes to really work with AI in the production environment to ensure acceptance.
Very good.
What you describe here is really the very profound symbiosis between operators, for example, or technicians in the plants with AI and these technologies. And it's not that AI is always replacing human beings in doing something. Also, a very important thing is that AI can support human beings to make better decisions, to operate plants in a better way, with more yield, with better qualities, with less issues, also with higher safety. It's also an important topic.
Now, before we go into maybe more detail regarding what now how to successfully apply applications and what are limitations and these aspects, I learned in the preparation of this talk that not always AI is maybe the proper or best method to like generate some insights for out of data or get answers of data. Or the other methods that might be proper according to the problem to solve or answers to look for.
This is exactly the topic where we say it's beyond the hype. In the hype phase, more or less every problem is targeted or was targeted with AI methods because it was considered to be the method to be, the method to solve more or less everything. But now, and we've seen that in different hype cycles already before, the new technologies, we now know how to use it, where are its benefits, where are its drawbacks, and where to apply it the best. And it's big, it's a huge tool with a lot of possibilities. It enables us many things we were not able to do before, but it's still a tool, and there are other tools in our tool set. All the classical methods, sometimes very first principle models and calculating things, classical computer graphics, things like that may help, may also solve the problem, and sometimes they are more efficient. So it really matters what problem to solve. I simply wanted to stress that again.
Okay, thanks. So if you have any questions, please just put them in the chat of this live stream. I will read out the most interesting ones to our speakers in our upcoming Q&A session. Now, when we talked about like the solutions we have, and I think there's a lot of programming behind, of course. Yeah, applying AI methods is different than like having an expert system in operation. So do you collaborate with a lot of startups? I think this is a topic where you have to be very agile, which is typical something startups are. Do you cooperate or do you develop everything yourself, or are you organized in that respect?
For sure, we are looking at startups. What are they doing? And we are also, if it makes sense for us, collaborating with startups. Startups are extremely good in applying latest technologies, and they are extremely quick. Speed kills is a saying. When we, and I'm talking about production now, when we bring solutions into production, we have to make sure that the solution is reliable, robust, and safe. And speed and robustness, reliability, and safety sometimes is in contradiction. No, it's most of the times it's in contradiction. So yes, we work with startups, doing proof of concepts, testing new technologies, But when it comes to really applying a new technology, AI technology, in our automation systems that are controlling the production, then we typically rely on our own expertise in how to set up robust, reliable, and safe solutions in this production environment.
So does this mean that also like Primetals Technologies had like to craft a task force with like AI know-how equipped within the last, I don't know, years?
We do have our own team of AI experts, and what it basically needs to apply AI in an automation environment, in the production environment, is three disciplines. You need the guys who understand all those new AI technologies, data scientists, and so on. You need people who understand the process, who know what they are looking for, where AI could help them. So metallurgists, technologists. And then you need the guys who are able to implement things in software in a robust, reliable, and safe way. And bringing these three together is our way to build solutions that can be operated in a production environment. And startups help us to come up with new ideas, do proof of concepts, apply new technologies. But really, when it goes towards deployment, we rely on our own competencies mainly.
Okay, very good. So I think we have the first questions from our participants. Let me quickly have a look before we continue our conversation. There were some questions. Let's see. My question is it possible to implement an AI agent system instead operators in a rolling mill? I don't know who wants to answer. Do you have any answer to this question? Whatever we understand for an AI agent, maybe this is again a word which is maybe not perfectly defined, but
if we're talking about agents that really take over all duties operators do today, especially in a rolling mill, I do not see that in the next years. We are currently working on things like a central operation cockpit. You definitely know that, where we aim at one person operation of a rolling mill. One person operation already requires a lot of things to be taken over by the automation. Also using AI-based digital assistants, for example, we have for various applications, and taking all the information that's necessary for operating the plant and displaying that at the right moment to the operator so that he will be able to run the plant. But to be fair, in such a complex machine like a rolling mill, there will always be situations where you would need a human being to react. At the moment, and I've been to plenty of rolling mills already, I cannot imagine that the automation is really capable to take over proper action in each and every situation so that there will not be any operator anymore.
Is this exactly what you described first, that AI learns from humans and human learn from AI, this like coexistence?
Going into that direction, definitely, yes. And I totally agree with Alex. Just imagine how many cars, we talk about autonomous driving, and an agent operating a rolling mill would have a similar task than an agent driving a car. How many cars are out there to learn from the human behavior of a driver and train an agent? And how many similar rolling mills are out there? So just starting from that aspect, there is a huge difference. We don't have that many rolling mills in operation worldwide to be really able to train an agent that can operate on its own. And we know that, mean, that would be a philosophical discussion, but in cars it works under certain circumstances and under certain preconditions, but not always.
Yeah.
And that shows that maybe this will happen sometime, but I don't see that for the near future.
Yeah.
If it's even not really working properly yet, I mean, the progress is astonishing, but it's not really working properly yet in cars. On a rolling mill, it will take much longer.
Yeah. Okay.
There are similar topics we always face. Again, a car example. Many cars today now have speech models to control the behavior of the car. But typically what you control is maybe your phone, your radio. You're not controlling your speed typically with your voice.
Right.
And that's the same. Consider that how much money went into the speech control of such a car. Now consider speech control of a rolling mill, for example, taking over AI at such a high level. At the moment, I cannot consider that.
There will be, let's put it like that, there will be AI agents supporting the operator.
Yep.
Yes.
Sounds reasonable. There's another question. So what mechanisms has Primetals put in place to validate steel data they use in production? Anyone of you would love to this question?
To ensure quality, again, there is AI methods, but also like good old mass balance helps very often to see if the data can be correct. So, or first principle models can help us to investigate if data is reasonable, at least, can be correct, if there is no contradiction in the data. So again, a combination of classical methods and AI or machine learning methods are used to validate the data.
Pretty cool. Okay, there are some other questions. Maybe we keep that for the next Q&A session. Please just keep on adding your questions to the chat. Thanks for your interest. We were talking before about the robustness of like solutions, which are obviously necessary, especially when it comes to steel industry. So understood that these solutions have to operate 24/7, 365. And when we were preparing for this talk, you told me, I think it was you, Kurt, that Primetals Technologies has a digital product-based approach, and there's a big difference compared to just supplying a digital solution to solve a problem. And especially when we talk about AI, this has like benefits. Maybe you can a bit elaborate on this.
I wouldn't say that it has only benefits with AI. This is a more general topic. 30 years ago, the automation had some level 1 and maybe a level 2 system, and that was it. Now we are operating in a much more complex automation environment. The software systems are exploding in the sense of they get bigger and bigger. And we face challenges like cybersecurity. 30 years ago, software was installed, and after 10 years, 15 years, it was thrown away and the new version was installed. Today, we have connected systems. The level 1 of a production unit is somehow connected to the internet. And cybersecurity is one of the central challenges. And to ensure cybersecurity in this complex automation architecture, I have to know what is installed, to identify if there is a risk somewhere, to identify where the risk is. And if I want to fix that problem, and I only work with tailor-made software, it gets close to impossible. So this is why we have this product-based approach, means we have a core of a product that is continuously developed, where we put our innovation in, and there is an area in the software that should be rather small, that is configuration, where we adopt the software to the plant, to the real use case. And that enables us to provide this lifecycle management for the software. For sure, improve functionality of the software, but very central, if there is cybersecurity issues, we can quickly provide bug fixes. And that is something that we apply on, call it classical software, but also on AI models, to really make sure that when we provide software, we can maintain the software not only for half a year, but over the years. Even in a way to say, okay, there is this continuous improvement. You don't buy the software, you go for a subscription model, and you can be sure you always have the latest software. And after 10 years of this subscription model, your software you're using is a completely different one than the one you started with, because it has been continuously changed and improved. And this is only possible if I really work product-based and not do customized applications, start from more or less scratch every time.
This reminds me actually on my good old times. Just believe me or not, 25 years back, I was programming myself, not very sophisticated, to be honest, like CC+ was like my maximum level. And I remember saying at that time was like, never touch a running system. So obviously Primetals does not follow this methodology or this.
No, we say prepare the system to be touched.
Oh, very good. We were just already touching the topic of domain know-how, and I used this at the beginning when we're talking about like why is methodological know-how so important, to just maybe pick the right methods, or Alex, you can just say what is like the importance of the domain know-how when it comes to AI applications or maybe other ones.
We clearly see in all different use cases where we apply AI, almost all of them come also from our customers who ask us for special use cases. Can we support them in those use cases? And typically, these use cases sound very simple in the beginning. A very clear task to fulfill. And then we start discussing. Also, what shall really be the outcome on the one hand side? But on the other side, what's the real problem you would like to solve? Where do you would like to apply the AI? For that, you really need to have technological know-how to discuss that. And if you go on discussing, typically the use cases become more complex, but the value of the AI later on, the output is also far higher. And to be able to also to consult our customers to some extent and to have these discussions with the technologists, you need to have this expert know-how at hand. And for that reason, it's very important that our AI specialists and the IT guys Kurt mentioned are really working also locally close together with our experts in the field, basically to share the same coffee table, to have the same lunch breaks together, and to talk about these use cases, and to have this openness to discuss these topics and to learn from each other. It's really a fruitful thing, and in our company, this is really a spirit.
So then I suppose, I mean, I just remember maybe 2 years back, there was this kind of like some company stated, put the data in a data lake, then I just come with my AI, put it on top, and you earn a lot of money. So this was maybe before the hype curve just going down.
I remember discussing with a customer one day, and he said, yes, we did the same with a data analytics company who had no domain know-how. And we gave them some data, and then one day they came back with a big smile in their face. Look what we found out. The elongation of the strip in the rolling mill has a strong correlation with the roll gap. So yes, this is true, because this is not AI, this is physics. That's the intention of a rolling mill. But those guys didn't know that. They did some data engineering and said, yes, there is a strong correlation. Yes, for sure there is a strong correlation. So someone who knows rolling mills would never come up with this, because this is obvious. And someone who knows rolling mills knows where are the let's say, where do we suspect unknown effects which are there? This is the interesting thing. Find the unknown effects which are there. And to do that, you need to know where to search. So if you're looking for a needle in a haystack, you should better know what the needle looks like.
Yeah.
And there is a lot to find. We've done that on our through process quality control system, where we collect all the quality relevant data along the entire production chain and really identify what is the impact of something that happens in the melt shop or on the caster on the quality of the finished product with data correlation. So this is not obvious any longer. And we could even identify what's the good range for those parameters to optimize the production. Again, not obvious. How could we find it? Because there were people saying, okay, for sure, what happens on the caster has an impact, and these might be the reasonable parameters, and then use AI, saying, okay, what are the parameters that have most impact? And then with different type of AI, identify what is the right range for these parameters to produce the wanted outcome. Just with not knowing what steel production looks like and data analytics, we don't think that it works.
Sounds difficult.
On a broad basis, yeah.
Right.
Yeah, here we directly see again, it's crucial also to know not only which questions to ask, but then also to know which methods to use in AI to have that. Now in our last 2 or 3 questions we were talking about, we already touched so many different application fields again of AI. And I simply would like to remind you what we started with in this discussion. We have data analytics topics now touched. We had computer vision-based topics touched. We had other sensoring topics touched, sometimes directly in the application with the operator, sometimes across the production over weeks or months in the quality system like our TPQC system. So this is really a broad topic we are touching here with AI, and really have this unique combination of the experts in the technology field together with the AI experts.
No, I think this is very good, like keyword, like a large AI or large application. I just have an interesting question here. I think this just goes in the direction general AI. I think we've touched it like at the preparation of this talk. One of our participants is asking, is Primetals as a pioneer in the steel industry working on developing an AI large language model that, using process data, can accurately answer any question related to processes from iron making to steel making? Sounds a bit like general AI for steel making in the plant, right?
Yes. We're looking at different applications of AI. Of course, large language models have become an important technology in the past years. It's not so long since ChatGPT really went into the big public of many, many people. It is there for longer. And of course, we are also considering reasonable use cases to apply that in our industry. But I would like to stress this reasonable. So, as we said, beyond the hype, the ChatGPT hype or large language model hype came a little later. It's now also decreasing a little, but now it's really the time to think about in which applications does it really help us to make us better, and to make our customers better.
Always with the idea to support operators and not have it in closed loop control.
Yeah. There's also an interesting question related to data. Maybe Kurt, I can hand over this to you. How does Primetals solve data source varieties? So the major problem, according to this participant in metals industry, is data history. So what are the answers?
Yeah, we have recently developed and deployed what we call data core and data warehouse. The idea simply is that all of our systems provide data in a specific, easy to access way. So we use these mechanisms on the one hand for communication purposes between our systems or our systems and third-party systems, but also as a data archive, even long-term archive, where I can easily access the data for data analysis, for reporting purposes, for BI purposes, and so on, to make really sure that you can gain the benefit out of the data. Data lake is a term that was broadly used. I don't personally like it. I always say it's typically a data lake is not a lake but a data swamp. Pushing all data into one database doesn't bring any benefit at all. If you want to use data, you have to prepare it properly, and this is what we do with this data core and data warehouse approach, saying, okay, when we store the data, we already think about how will this data be used in future and prepare it accordingly. So that means it's not some database structure as we need it to run our systems, but it's already a data structure as we or our customers need it to do machine learning or to do business intelligence. So prepare the data to be ready for use. This is the way we are going, and we see that this is one of the things our customers like very much, saying, okay, that's great. I, for example, have my own BI tool I use. If you prepare the data in a way, all I need to do is connect to the data and I can do whatever I want to do with the data. So that's the way we are going here.
Yeah, okay, cool. So thanks for your questions. We will have another Q&A session at the end of this talk. Please keep on inputting the questions in the chat. Thanks for all the inspiring comments so far. Now, maybe we just keep on discussing a bit when we talk about, like, I suppose when there is an AI solution, this should not be like a silo application and IT automation infrastructure of a steel plant. And I think, of course, it's not then even necessary to leverage the full power of the AI solution. As you stated, Kurt, of course, when it comes to just deriving actions and taking the actions out of what AI maybe just generated as insights, I guess the proper integration is super important. So I learned prior to this talk that Primetals Technology has a lot of AI applications in operation as steel producers around the world. So how do you ensure that the AI solutions that just came up maybe recently are really properly and perfectly integrated to the existing landscape?
AI integration is, as you already mentioned, an important topic. And we get more and more AI applications in the field. So in the steel plants, in the rolling mills. There are some rolling mills outside, meanwhile, with dozens of applications of AI in their daily operation. And on top, the AI mentioned in Kurt's system, like this TPQC for quality management, for our condition monitoring system, and so on. That's also an important topic now looking back at your point you had with the startups. A startup typically focuses at a special application or a special technology in AI in the market. But if you look on site, you have so many different applications. And if you would go for one application with one startup, for another application with the next one, and so on, you end up with a very heterogeneous landscape of your AI applications with different interfaces, with different tools, maybe different programming languages, maybe different hardwares you're talking with. So for us also as a system integrator on the one hand side, and as an AI provider, the software provider, especially in the electrics and automation, for us it's necessary to have that on a common ground, also to be as easy accessible to our users, to our customers as possible. So this is the reason, for example, why we have for many AI applications our deployment framework as a big basis that enables customizing, dealing with the AI for different applications, for digital assistants that support the operators, but also for other AI applications in one single framework where you simply put your AI, have that inside, but other necessary functions like supervisions of your AI. Is your model still running? Or if you would like to retrain a model, or if this is necessary, not only because some regulations have changed, but also maybe your production has changed, or your situation in the plant has changed because you did some modernization or some upgrade. Then you sometimes need to adjust also your AI application. And to have that ready in a stable way and in a harmonized way, and not only now, but also in the next 5 or 10 years, to have resilient solutions. That's an important thing. And this is what we can provide.
I would also expect that this adds a lot of value when it comes to cybersecurity following this
Absolutely.
approach, right?
Because you have one concept, also with login management and so on, and you can think in that layer all these topics of cybersecurity and shield basically your real applications down in the core.
Yeah, because I think I would get nervous if I would have to care about a lot of solutions that are all like existing individually in my plant infrastructure.
You would need to take care about all of them.
Yeah, right.
So in a nutshell, we provide the data for them for the AI modules with our data core for all applications, and we manage the models with a deployment framework, manage the models, retrain the models, monitor the models. And with this concept, we can ensure well-managed software.
Yeah. Now, talking about well-managed software, I think, Alex, you have just brought along with you a video where we can see one of the AI-based solutions in action. It's a vision-based solution. Maybe my colleagues can just show us the video, please. And maybe, Alex, you just can comment a bit on what we see here. Here the video is running.
Perfect. So this is one of our latest use cases we have deployed just a few weeks ago in a Scandinavian side. Here, it's a very simple use case, or that was one at the beginning, simply to detect the coil IDs on coils. So that was the initial. Customer asked us, they have a cold mill, that's an incoming train coming from the hot mill, and they would like to detect if the correct coil is on the correct position on the train to avoid some misalignments in the logistics. Basically, to avoid a lot of scrap at the end. What we see here is the final one, where we do not only read the coil IDs, which is also possible for handwritten ones. We also detect the wagon, the saddle number, and this is a good example where later on in the discussion, additional functionalities came up.
Cool.
And so we made it far easier now for the customer to control that and to avoid misalignments here.
Cool. So this one was an example of a like vision-based AI solution as opposed to like other ones.
Yes,
right?
We have different types of applications. I've already mentioned the acoustic ones. Some are going directly down in the automation in the level 2. Also acting, for example, is an adjustment closing the gap from the first principle models in our automation to reality. We have other models that monitor, for example, other outputs of the automation system. We have the ones already Kurt mentioned in the quality management system. Also, anomaly detection plays an important role.
Okay, cool. And so is it always like super straightforward when this application on the one hand looks like not like super complicated? Also, I think I know there's a lot of like technology behind and programming, but like using a camera and detecting, of course, looks like nicely. So is this always like straightforward and the solution is there within a short period of time, or is there also like examples where it's not so easy to find the proper solution?
Again, depends on the use case for sure. This example is not closed loop control. This gives a huge advantage. The machine learning model is not influencing the system. If you start to do closed loop control, and one of the typical applications of machine learning is building neural networks that are modeling the process, for example. And if I use this model, this machine learning model, trained based on historic data, to control the process, I stabilize my process. And then again, I use historical data to retrain the model. But I have data only available for a very stable process. This means my input data has no variance, no fidelity. This means that the machine learning algorithm is modeling something, but not the process, because the data is not covering the process, but only a very small spot of operating range. And if you then use the retrained model again for controlling, you again get data fidelity because the system does something.
Okay.
So you have a much bigger operating range afterwards again, which you don't want to. So that means as the system is, the model is very much stabilizing the process, it's more or less taking away the data fidelity it needs to be retrained.
Yeah.
So that means that, and we have done that, we needed to find ways to make sure that we are still getting data that is diverse enough to retrain the models, plus going a hybrid approach, saying, okay, we can use first principle models, simpler first principle models that make sure that the machine learning model is not starting to hallucinate. So there is a simple first principle model that takes care that the machine learning model is not doing something because the quality of the input data was not, or the fidelity of the input data was not good enough that it really worked training the model.
Okay, cool. So before we now have a look at the questions again in the final round, maybe I would love to sum up with both of you because I asked at the very beginning, what are like maybe key success factors when I'm as a steel producer would love to successfully apply AI in my plant? What do you think, Alex? What would be like some of these key success factors in your opinion?
As I said, it's the unique combination of the technologists on the one hand side that know our steel business for decades very often, and young, dynamic, inspiring people that have full of AI in their veins, the technology, and bringing them together. For me, also, it's always a pleasure to really see when they start discussing. And the big spirit, the positive spirit typically comes out of that. And I guess that's also what our customers feel when we talk to them about AI applications in the different applications we have mentioned today. And I guess this is a key factor of what we can provide on top of all the technologies we mentioned today with getting the data, with the data core and the data warehouse Kurt mentioned, with tools like the deployment framework to host the AI and to deal with all the necessary things you need to deal with. And it's also our commissioning people who have a good understanding how to really bring things in operation on customer sides.
Cool. Good. Well, something to add from your side about key success factors?
If you want to apply AI technologies in the production surrounding in a sustainable way. Make sure that your data quality is good. AI has extended our toolbox. You need the competences to use those tools. And when it comes to implemented applications in the production, the lifecycle management of these software applications is decisive. So get the right input data, know how to use your tools, and make sure that you can maintain your solutions over the years.
Very good. So let's look at your questions, final round. So there is one from one of our participants. How are the responsibilities of AI people and technologies kind of like separated or defined in your opinion when talking about applying AI solutions? How shall they collaborate with each other?
Best is to have curious people. It's not that much about responsibility, and can be a curious metallurgist who is interested in machine learning methods, can be a curious data analyst who is interested in metallurgy, and this curiosity is what brings the success. From a responsibility or organizational point of view, I cannot answer that question. I would go that far and say there is successful applications of AI, although there is an organization.
Good point.
And in our case, we have people that know how to use AI technologies in our technology departments, metallurgy departments, as well as in our automation and software departments. It's as I said, you cannot manage that with organization, but with curiosity and collaboration only.
Good point. Maybe last question. I have a line of time as well. So one participant is asking, what are the key challenges and best practices for integrating AI-driven solutions with existing systems with outdated protocols, low data accessibility, and without disrupting production? Sounds like a mission impossible, doesn't it?
Yes.
There are a lot like mission impossible, but to be honest, it's daily business. Again, data preparation. This is something you can typically set up in parallel to the production, because the question was in production. So extracting and preparing the data out of the existing systems. Let's even go one step further back. Understand what data is necessary for the use case. So I prefer the approach saying, okay, if this is the use case, this is the data we need. Where are the systems? Extract them, store them, prepare them for use. And if I've done that, it's actually the worst part of the thing. If this is done, I can then use the deployment framework, saying, okay, this is where I train my models, this is where I deploy my models, and use the data I've extracted to apply AI technologies. It's the biggest challenge in this existing inhomogeneous surrounding definitely is the data extraction.
Very good. So now we have reached the end of this Pioneers talk. I would love to thank you, Kurt, and you, Alex, for being here with us in our studio and for answering so many questions from our participants. And what about you? Are you now even more enthusiastic about AI in steel production? Could we maybe overcome a bit of your skepticism about AI? Well, within the next couple of weeks, we're going to share some use cases on our LinkedIn channel. Just be sure to follow Primetals Technology not to miss them. And I would be happy if we would stay in touch as well, so that you can attend one of my next upcoming online events. So stay connected and goodbye.